Okay, guys, back over here again. Let's see. All right. So we have, let's see, we have identified our functional dependencies. And so once we've done that, we can begin the process of normalization. So if we imagine that this table here, the staff property inspection, is a first normal form table, meaning we have all of the rows, each cell has an individual value, a PG4, a date, a time, an address, a comp. Everything has a single value. Nothing has more than one value in it. And there is a primary key defined. So we define, so we'll go ahead and go with their system. Fatih Furkan, again, I'm going to go on record that I agree with you that time should be included, but they did not. So I'll let the textbook authors override me on this one. Okay, but we have our primary key defined. So now we have a first normal form table. So in order to get our first normal form table into second normal form, what do we have to do? All right, so we are going to go from first to second to third, and we'll talk through this whole voice cod thing too, just for the fun of it. What do you think? What's the first thing we got to do? I will go back one slide to show you all of our functional dependencies here. Right, so we need to get rid of partial dependencies. What is our do we have any partial dependencies? Right, so property number determines property address. So what we'll do to get to our second normal form, okay, we will create a property inspection table, and let me go ahead and show you this one that's going to show up down here at the bottom too. Okay, property table. Right, and what this represents, so we'll have a property table and a property inspection table, right? And what that means is, so these two columns here will be our property table. This column, along with everything else besides the address column, will be our property inspection table. And so basically what this is we're saying these two columns together will be property specific information, its address, and maybe some other things, that we didn't necessarily include in this example data, right? But then that property number will be used as a foreign key back to this table to represent that property identifier, along with all this other information to represent the inspection itself. So now we have a property inspection table that has all those other columns and a property table that has just the property information. Okay. We have second normal form. We need third. How do we get to third? said it. Yeah, transitive dependencies. And if only it weren't written right here. Right? What's our transitive dependency? Well, it's that staff information, right? So what are we going to do? Okay. Now what we'll have is this staff table. Staff table that's going to have just the staff specific information. We'll leave the staff number column in our main table, our property inspect table. That represents who the staff person is. We'll leave that column there as a foreign key to the staff table. Now, again, one thing I want to point out, once we've reached this point, the third normal form, for your group projects, that's enough. Okay, there's no expectation for you to go beyond this. Okay, but at least I do want you to understand that there are higher normal forms. I want you to at least be knowledgeable about these higher normal forms. Okay, and so the next higher one, the Boyce Cod, is we're going to look at this the problem that exists is that we have this candidate key that determines one of the primary keys and or a column that exists in the primary key, and that can't really exist, and that can't be a thing that we can allow to have happen. And so what we'll do in order to resolve this we'll create a staff car, which is the combination of the staff person using a car and an inspection table that represents when they went out with that car to perform that inspection. Because remember, the whole point is that those other candidate keys, what they were saying was that a person cannot be in two places at the same time. A car cannot be in two places at the same time. And so what we'll say is we'll have this central table that's the inspection. It's the when the property was inspected. And we will say the other table that's involved is representing the staff car combination that was used to make that inspection happen. Okay, so back to my question when I said, we said of those 8 columns, how many tables will we make? Right. So if we wanted to get this all the way into Boyce Cod normal form, we would need 4 tables in order to make this happen. To third normal form, we would only need 3. Okay. And Boyce Cod isn't even the highest normal form that we can get to. We can go higher. We can go to the 4th normal form. And the idea of the 4th normal form, and I am not going to go into super detailed, like even as detailed as the slides are, I'm not even going to go to that level on this discussion today because of how rare it is for what you guys need to know, how rare it is for anything beyond 3rd normal form to be a problem. Okay, usually once you get to 3rd normal form, all of the other forms are already covered. Okay, the idea though, I do want you to understand the concept of what's called a multi-valued dependency. Okay, the idea is that for one set of attributes, there could be multiple values that are dependent on it in the other side. So let's just look at an example here. So here we have, if we had the branch number and staff who work at that branch and owners who own properties that are managed by that branch. Okay. Here, notice that in order to have all combinations covered, we end up having this duplicated information, all right, where Anne works at the certain branch and Carol owns a property that's managed by this branch, but David also works at this branch. But in order to have this row show up, we're going to have this as well. And it's built on this problem is built on the idea of the whole cross product, right? The cross, not cross product. That's a math term. I can't remember. My English is slipping away the more Turkish I learn, but that's a good problem to have. Okay. But the idea is that in order to have this combination, because it's really the real problem here is that Anne and Carol don't really have any type of relationship, and yet they're in the row together. And the reason for that is because these are staff. If we have a column that's the staff that work at a certain branch, and we have another column that's the owners that own properties managed by a certain branch, they have to show up, right? Yeah, I think you're right. It's Cartesian. Yes, I think you're right. It's been a long time. Since I did high-level math. Okay. And so the way that we resolve this problem, has to do with we take each unique value from the staff name and we make its own staff table. So now we have a branch staff, so staff working at a particular branch. And we also have an owner table. All right. And so now this way we don't have duplicated information. But the idea is that in this example, that staff name and owner name have what's called the multi-valued dependency on branch number. For each branch, there is a set of information that would exist over here. Okay. And one of the reasons why we wouldn't necessarily just say, oh, well, this is a partial, it's not a partial dependency, right? There's no partial dependency here. Staff name is determined by branch number, or sorry, branch number is determined by staff name. Right? But at the same time, owner name also determines branch number. And that's where the problem is, that there's not a strict single full dependency we're looking at. There's two full dependencies. The branch number is determined by staff name. It's also determined by owner name. Okay. All right. So that's fourth normal form. So this whole idea is the multi-valued dependency attributes. Right. Okay. And I want to point out again something that I've mentioned, hopefully mentioned before. As we keep moving up that normal form hierarchy, as we keep moving up into higher and higher normal forms, each one is defined as a relation that is in a certain normal form, right, and contains some higher level of restriction. Remember that we said, okay, a first normal form database, or the first normal form relation, was one that is unnormalized, but has every cell has a single value and it has a primary key defined. Then we said a second normal form relation was a first normal form relation that has no partial dependencies. Then we said a third normal form. A third normal form relation is a second normal form relation that has no transitive dependencies. Okay. Then we said Boyce-Codd. A Boyce-Codd normal form is a third normal form relation that has, what was the special term we used? That has no, none of these specific types of dependencies. There wasn't a special name given for these. All right. And now we've gotten to the fourth, and we've said a fourth normal form relation is anything that's in Boyce-Codd and contains no non-trivial multi-value dependencies. Right? So basically what I'm getting at is, I'm going to come back to this again. I'm going to say this again. Your group project, once you get it, the reason why I wanted you to get it to third normal form is because for most of you, once you get it to third normal form, you don't have any of this higher thing. So you're basically putting it into the fourth and fifth normal form anyway. Okay. All right. And then finally, fifth normal form. It's a little bit difficult to follow. It's a little bit harder to understand, but the idea is this whole concept of what's called a lossless join property, so that when we join two tables together, we reunite two tables through a natural join. Number 4 on your group project list of things that you have to do. You're going to join all your tables together to hopefully recreate your original data set in a dynamic format, right? To recreate your original table, your original unnormalized or first normal form table visually, but it won't be another table. It'll be a view. It'll be a view that joins all of your new tables, all of your third normal form tables together to recreate visually what your original table looks like. Okay, and when you do that, hopefully there won't be any extra tuples, extra rows that didn't exist before, right? But it could happen. Right. Okay. So the idea is that when we have some of these different tables, like if you have a supplier who supplies to a particular property, when we join these things together, so we join a bed, supplier number, and property number together, right? When we add a new row in, we may end up getting some extra tuples, right? When we add the PG16 bed S2, right? The problem is that you have a PG4 bed, but bed has both S2 and S1. So therefore, and PG4 has S1 and S2. So the extra tuple that would be that would be added would be this one here. Okay. Again, I don't want to get into it too much with you guys because it is such a high level of a problem that so rarely shows up that that it would just be probably more headache than it's worth to really get into a deep discussion. But I will say this: if it's something that interests you, if you are someone who if you're someone who really wants to research databases and really become, like a database administrator or a data administrator, then it may be something that you'll want to know more about. For most of you who, like me, you just want to be a programmer, you just want to go make some nice systems for people to use. You'll need to know what we've talked about so far in terms of the SQL. You'll need to know about how databases are structured, but you probably won't need to know some of those higher level normal forms and higher level details of how to avoid update anomalies and stuff like that. So, all right. So we'll end there for today, unless there's any comments or questions. One other thing I did want to go ahead and remind you of is that tomorrow morning, the first thing I'm going to do with you guys is midterm review. Okay, so we'll talk about the midterm details tomorrow morning, 8:30, bright and early. Drink your coffee if you have to wake up. Okay, then we will move on into introducing the design phases of a database. So we'll start with conceptual design, and we'll give kind of a bird's eye view of all the different design phases. A data engineer, do you mean a data engineer or a data administrator? I'll stop the recording and we can talk about that.